Hello, I am Scott Beers.
I'm Bridget Lewis.
I'm Trenton Mallory.
And I'm Noah Cohn.
And we are here to introduce our solution for Pennsylvania, which we are calling EcoVolt Battery Recycling. We are all juniors of the class of 2026 at Glendale Junior Senior High School, and we are excited to show you our project.
When we began our research for our project, we originally had a wide variety of ideas, and eventually we decided that we wanted to focus on an environmental topic.
After we decided on the category of the issue, we then had to narrow our focus down to a problem that many Pennsylvania residents face. Eventually, we decided that PA residents lack access to recycling or simply don't know how to recycle. Battery recycling in particular is one of the most neglected forms of recycling.
Globally, only about 5% of lithium-ion batteries are recycled. This means that every year, over 3 billion of them are thrown away. Not only is this bad for the environment, but it also means that in total, Americans throw away millions of dollars worth of materials in the batteries every year. Some of the materials used in lithium-ion batteries, like the rare earth metals, create the need for an energy-intensive mining process. 95% of the materials within the batteries are recyclable, so recycling can prevent these materials from going into the landfills and needing to be mined again where they can potentially be hazardous. In addition, forecasted demand for lithium and other materials within the batteries is expected to exceed supply in the near future, so recycling could help to fill in the gap.
To be able to come up with our design, we looked at the engineering design process for some help. We focused on a problem in our area early on, recycling. And then narrowing our research to batteries was something we all agreed on.
We recognized the need for easy, simple, and incentivized recycling to create concepts for our project. We decided we needed to create something that could exist in common locations like grocery stores or pharmacies throughout Pennsylvania for battery recycling. We eventually decided on building a kiosk that could provide these factors, as well as serve as a solution for education.
For our project, we each focused on different aspects of the design according to our skills. I focused on research and communication, in addition to compiling a list of supplies that we needed to obtain within our budget. I also worked with Bridget to decorate and construct our kiosk out of lumber and the other materials needed. We mounted the touchscreen display as well as the neon lights and stickers on the machine.
I focused on designing the kiosk and incorporating art into our project. I created the blueprint for the kiosk, in addition to collecting measurements for the design.
I have experience with coding, so I focused on programming the motors, scales, as well as creating the graphical user interface that users interact with on the kiosk.
I focused on connecting all the hardware components together. I researched all of the terminal connections available on the Raspberry Pi and connected the hardware to it. I connected the servo motor, scale, buttons, and touchscreen together.
Now you may be asking why we decided to build a kiosk instead of just relying on drop-off boxes. We wanted to create something that was eye-catching to the public and would incentivize people to use our solution. Our kiosk acts as a billboard for battery recycling, and we've included an onboard digital scale to weigh batteries turned in by our customers, as well as a camera that can be equipped with image recognition services in the futures. For lithium batteries, many recycling companies offer money for the materials. This could pay for the service, and our system would work perfectly with a state or federal recycling deposit system.
We then contacted PA Senator John Fetterman's office to share our proposal for a deposit system. Under our proposed system, customers would pay a small deposit fee, like a core charge, whenever they purchase a battery. Then, whenever the battery reaches the end of its lifespan, the customer can return the battery to the kiosk to receive a full refund on the initial deposit. This would not increase the cost for the consumer, as long as the battery is recycled. The representative from John Fetterman's office gave us feedback on the program and suggested that in addition to our approach, we could also propose other systems such as tax credits or incentives for battery manufacturers who support recycling.
The first thing we began working on was the scale to weigh the batteries. We began by obtaining a load cell and an HX711 amplifier to communicate with the Raspberry Pi that we were using to power the interface. We collaborated with our school's shop teacher to cut two 10 by 10 inch platforms.
The scale is intended to provide statistics on the total amount of batteries collected over the kiosk's lifespan. In addition, the scale could also be used to weigh the batteries to determine the total amounts of incentives that users could receive from recycling.
Then used a Raspberry Pi 5 that Trenton connected to the load cell to interpret the signals coming from the cell to pounds. I had to calibrate the scale so that the existing weight applied onto the scale would not be factored into the final weight.
While they were working on the electronics and software components of the kiosk, I was working on the design. We worked with our school maintenance engineer, Kevin Hamilton, to construct the cabinet for the kiosk out of wood. I created a blueprint with all the necessary measurements for the cabinet. We decided to paint the cabinet a dark blue that would contrast well with neon blue lights. The lights themselves create the outline of a battery, resembling a positive battery terminal. This creates an eye-catching design that could stand out from other things that could be located around the kiosk. We also purchased neon lightning bolt signs to contrast the colors well. I worked with Noah to incorporate high-definition images into our user face as well. As a final touch, we added used batteries to the exterior of the kiosk to showcase recycling and how the materials can be repurposed.
I then worked with Bridget's design to create a 3D model in which we could visualize our design. Next, we wanted to create a holding chamber in which the batteries could be individually photographed for identification purposes. The user will begin the process by selecting the battery chemistry that they would like to recycle on the touchscreen's display. Then, the interface will guide the user through the process, prompting them to tape the battery terminals for safety purposes before they place the battery in the holding chamber. In the holding chamber, the battery will then be weighed and photographed before being sent into a lower collection bin. In the future, we plan to incorporate image recognition into the software to prevent unwanted items from entering the collection bin.
To create the interface that the user interacts with, I utilized available open source code to help me get started. After the user places the battery into the holding chamber, they will have to close a door, which will then press a switch, starting the sequence. The code will begin by capturing an image and assigning it to the weight and time the battery was collected. In the future, we plan on working with representatives to create universal labels that are printed onto batteries in which the kiosk can scan to determine the incentives the user should receive. Then, after the weight is collected, the software will communicate with the servo, signaling it to move. At this point, the total weight of the batteries collected will be displayed on a counter and the process will end for standard recycling. If incentivized recycling is implemented, the user could enter information into the system which would display a code or receipt for the user to access the credits they received.
While developing our prototype, we ran into several issues along the way. To begin, the door indicator switch wasn't registering an input when the door was closed. After some experimenting, we were able to determine that the button was bouncing aside, essentially clicking faster than the software could recognize.
To mitigate this, we added a delay value in the software to allow for a button press to register.
We also have experienced several bugs with our software, which we are actively working on fixing. Once everything is ironed out and finished, our software would function like pictured in the video. We are also collecting feedback on various aspects of the user interface. We are working on it to make it more user-friendly.
Due to time, space, and budget constraints, we had to change the design of our kiosk to accommodate a smaller tabletop footprint. The overall functionality of the kiosk remained the same, but we were able to save time and make the unit more portable. As a result, our prototype can be thought of as a scaled-down version of our final product. Once the software and hardware materialized for our project, we began mounting the Raspberry Pi, scale, cameras, and displays onto the cabinet. It was difficult to appropriately manage all of the wires, so we zip-tied sets of wires together depending on the task they had performed. We also had to purchase some extension wires for our Raspberry Pi, as the existing wires for the servo motor weren't long enough. And we used the mounting screws included with the touchscreen to mount it to the desired location. For the Raspberry Pi and breadboard, we had a custom mounting board made to keep the two close together when mounted. Once everything was complete, we had our kiosk made.
As stated by Noah, we are testing the kiosk for our user accessibility and are working on the user interface and messaging.
We also plan on adding a headphone jack and numerical keypad with braille digit to expand accessibility even further.
Alright, so I'm going to show you guys how to use our kiosk. So as you can see right here, we have a battery that we're going to recycle. So to begin the process, we touch the screen, and then we take a look at the battery, and this is a lithium-ion battery. So on the touch screen, we're going to select lithium-ion battery recycling. Then the interface is going to guide us to tape the exposed terminals of the battery. Now this particular battery doesn't have any exposed terminals, so they don't have to be taped. So from there, we are going to place the battery onto the platform, and on that platform we're actually going to have a door in the final design. And as you can see, there's a camera up here for image recognition, and that's going to be down inside of the door as well in the final design. So then we take the battery, and the scale is located inside of the kiosk. So we take the battery and we place it onto the scale platform, and then in the final design you'll just have to close the door for it to work, and the battery will drop down into the collection bin where it will be weighed and collected for recycling. Battery recycling will have a bright future in Pennsylvania if our kiosk and policy solutions are implemented. We aim to help the environment and the United States by bolstering energy independence through creating a circular economy of materials within the country and eliminating the need for imported batteries and materials from countries like China.
Thank you! We hope to continue improving our project for the greater benefit of the people and the environment.